it's me, Dr. Atika. Again, so we have a new chapter today, chapter 4, analysis of variance. So we have done our chapter 1, all the term. We have done our chapter 2, all the measures. We have done chapter 2 is the confidence interval. And then we have chapter 3, the hypothesis testing. So now we have chapter 4. So all the way here until chapter 4, analysis of variance, ANOVA. So what we have here is, what we have to do in our chapter 4 is we want to compare more than two population mean. If you have two population means, you can compare using hypothesis testing. But if you have more than two population mean, you want to see the similarity or the differences, you cannot use hypothesis testing. You have to use what we call it as analysis of variance, ANOVA. So let's look at what we have in chapter 4 here. The content. So we have 4.1, introduction is ANOVA. What is ANOVA? 4.2, we have one-way ANOVA. We have two-way ANOVA, and then ANOVA using Microsoft Office Excel. Okay. Analysis of variance, ANOVA. ANOVA is a short form of analysis of variance. Okay. Completion of this chapter, you should be able to use one-way ANOVA to determine if there is a significant difference among three or more means. So we deal with more than two population mean. Okay, and then for the two-way ANOVA, we talk about the interaction. So a quick concept for one way, we talk about the difference between mu1, mu2, mu3, and so on. Okay, in two-way, we talk about interaction. Okay, is there any interaction between two or between two factors, right? So next, okay, introduction to ANOVA. So in this 4.1, we will describe the purpose of ANOVA. So what is the assumptions in the ANOVA, and what is the procedure to solve ANOVA. So actually ANOVA, we also will use hypothesis testing procedure. So let's recall back hypothesis testing procedure. Step number 1 is formulate the hypothesis. Step number 2 is test statistics. Step number 3 is critical region. Step number 4 is decision. You want to reject or accept National. And step number 5 is the conclusion. Okay, what is ANOVA? ANOVA is the short form of analysis of variance. We make conclusion about the mu population mean, but we will use the variance. So normally we will use variance to compare the groups. Okay, the purpose is we want to compare the differences of more than two population mean. So let's say you have mu1, you have mu2, you have mu3. You want to know if these three population mean equals or not. Can you use hypothesis testing, traditional approach? No, because hypothesis testing only can compare two population. When you have more than two population, you have to use ANOVA to compare the difference, to compare the similarity. Okay, it is also known as factorial experiments. Okay, the approach that allows us to use sample data to see if the values of more than two population means are likely to be different from each other. We want to compare the population, but we will use the sample. So the same in your chapter 2 there. Okay, the name is derived from the fact that in order to test for statistical significance, we could mean we are actually comparing variance. Alright, so when we talk about variance here, comparing variance, we will use the F distribution. We will use the F test. So no more Z, no more T, no more chi-square. This one is F distribution. Okay, there are two types of ANOVA, as I mentioned earlier. One-way ANOVA involve one factor, involve one independent variable. Two-way ANOVA involve two factors, means that two independent variables. So you have to know the definition of the dependent variable and the independent variable. So what is the difference between hypothesis testing and the ANOVA? So hypothesis testing, I mentioned only for two mu. Okay, when you have more than two mu, you can use one-way and two-way ANOVA. Okay, for example, will two different methods of teaching have effect in student final mark? So you have two different methods. So only two methods. So you want to compare these two methods. You can use hypothesis testing. Right. So now, will three different methods of teaching have effect in student final mark? No, you have three methods. Can you use hypothesis testing? No, because you have three mu now. So you have to use the one-way ANOVA. So look at two-way ANOVA. Will three different methods have effect in the four faculties? Now you have two factors. The first one is different method. The second factor is for faculty. Is there any effect between different method in the four faculties? So this one is the two-way ANOVA. We'll look at later on one by one-way ANOVA and the two-way ANOVA. So these are the procedure to conduct the ANOVA using hypothesis testing. Step number 1, as usual, you must have your H null and H1. Okay. Step number 2, you want to find the test statistic. In ANOVA, the test statistic is only F test. In order for you to get this F test, you have to construct the ANOVA table. Okay, so next for step number 3, critical region here. Okay, make a decision. We will reject H null if your F test greater than your F critical value here. Reject H null if F test greater than F critical value. We will use a right tail test greater than. Okay, and then you draw conclusion. So this one is step number 1, this one is step number 2, step number 3, step number 4, and step number 5. Same in your hypothesis testing. So next, what is one-way ANOVA? One-way ANOVA involves one factor. So always remember that it's involve one factor. Means that one factor, one independent variable. I use IV for independent variable. Okay, in one-way ANOVA, we want to determine if there is a significant difference among three or more population mean. Okay, for example, you have one population, two population, three population. Okay, you have mu1, you have mu2, you have mu3. You want to know, is there any similarity among these three mu? You can use one-way ANOVA. Right? So what is one-way ANOVA? It's involve one factor. Factor come from independent variable. Okay, so independent variable factor. Sometimes we call it as control variable. And then one dependent variable or response variable. The replications come from the dependent variable. Okay, so in one-way ANOVA, the first thing that you need to know is the independent variable. Second is the dependent variable. Third is the factor. Fourth is the replication. Okay, replications come from the dependent variable. Factors come from the independent variable. Right? So these are the assumptions when you want to do ANOVA. The assumption is the population must be normal distribution. The samples drawn, each sample is independent. It cannot be related to each other. And then they must have same unknown population variances. Okay, these are the assumptions. So the tabulation of data, how you want to tabulate your data. So here replicates I mentioned is the dependent variable. So treatment is your factor, come from the factor. Okay, factor come from independent variable. So you have independent variable. From this independent variable, you will have factor. Okay, from this factor, you will have treatment. Right, so from these all, you will have the model later on. Okay, so x11, x21, this is all data. Okay, total is total row 1, total row 2. So don't worry much, we will look at later on. This is just a tabulation of data, the concept. Okay, the model for one-way ANOVA is xij equals to mu plus alpha I plus epsilon ij. Alpha I here is the treatment. Mu here is the overall mean. Epsilon here is the error. Where your I equals to 1 to up to K. So K here is number of treatment. And J is 1 to up to N. N here is replications. Okay, you have K. K is treatment. And you have N. N is replication. So I repeat again. Treatment come from independent variable. Replication come from dependent variable. So these are the assumptions. Two rules must fulfill with these two assumptions. Okay, step number 1. This is step 1 in ANOVA. Conduct the null and alternative hypothesis, H null and H1. So H null in one-way ANOVA. H null is mu1 equals to mu2 equals to how many treatment you have. Let's say you have K equals to 3. So you will have H null mu1 equals to mu2 equals to mu3. If you have treatment until 4, you will have H null mu1 equals to mu2 equals to mu3 equals to mu4. Okay, or you can write down in words, all population means are equal, acceptable. Or no difference between population mean, also acceptable. Okay, if you write down the H null similar, what will be the H1? H null is not equal to. So mu I is not equals to mu j for at least 1I not equals to j, where I j equals to 1 to up to k. Or you can write down at least one population mean is different. Not all is different. At least one is different. Okay. All population mean are equal for the H null. And then for the H1, at least one population is different. Or there are differences between the population mean. Or not all population means are equal. So either one. You want to use symbols or you want to use words, it's acceptable both. You give the same meaning. Okay, done for step number 1. Step number 2 is the test statistic. So here, ta-da! Alright, so now is step number 2. We actually want to calculate the test statistic. Okay, the test statistic, as I mentioned, for one-way ANOVA, we will use F-test. Okay, the formula to find this F-test is here. F-test is equal to MSTR over MSE. What is MSTR? What is MSE? MSTR is mean square treatment. MSE is mean square error. So we move to here. How to get MSTR? MSTR equals to SSTR divided by K minus 1. What is SSTR here? So SSTR given by this formula, K minus 1 is the degree of freedom given by this formula. So you will get the MSTR. So SSTR divided by K minus 1, you will get the MS treatment. Okay, MSE. How do we get MSE? MSE is from here. MSE is equals to SSE divided by N minus K. What is SSE? SSE is sum square error. Sum square error is equals to sum square total minus sum square treatment. Sum square total is here. Okay, this is the formula to find sum square total. Okay, sum square total and then sum square treatment. How do we get sum square error? You just minus sum square total minus sum square treatment. You will get the sum square error. So here, what is capital N? Capital N is the total number of data. Minus 1, you will get degree of freedom total. Degree of freedom treatment minus 1, you will get degree of freedom treatment. And then here, degree of freedom error is degree of freedom total minus degree of freedom treatment. You will get degree of freedom error. Okay, so I repeat again. In step 2, we want to find F-test as your test statistic. The formula to find F-test is here. Okay, so in order for you to have this F-test, you have to go through all the process. So you have to construct this ANOVA table, right? So step number 3 is here. Step number 3 is here. This one is step number 4. Step number 3 is the critical region. We will take F alpha, right tail only. K minus 1 here is degree of freedom treatment. Nu1 and Nu2 is degree of freedom error. Degree of freedom error. So take note that one. For the critical value, step number 3 in ANOVA, F alpha Nu1, Nu2, where your Nu1 is degree of freedom treatment here, and then your Nu2 is degree of freedom error here. What is capital N? Capital N is the total number of data. Okay, you have your F test, you have your critical value. You want to reject or accept H null. Here, the null hypothesis H null will be rejected if F test greater than F critical value. Reject H null if F test greater than F critical value. This F test greater than this F critical value, reject H null. So now, how to calculate SST, SSTR, SSA? You look at your stat table, you have this formula. Okay, how to find SS total, how to find SS treatment, how to find SS error. Look at the formula in your stat table, you will have this formula. Okay, look at the example. An experiment was performed to determine whether the annealing temperature of ductile iron affects its tensile strength. So, dia nak kaji whether the temperature affect the tensile strength. Is it temperature affect the tensile strength? So, the tensile strength depends on the different temperature. So, the tensile strength will be a dependent variable. Because tensile strength different on the different temperature. Temperature will be the independent variable. 5 specimens were annealed at each of 4 temperatures. Okay, the tensile strength was measured for each temperature. The results are presented as follows. You have here temperature is your independent variable. Also will be your factor. Okay, the tensile strength here is your dependent variable. Okay, now you have the independent variable, the temperature. Dependent variable, the tensile strength. The factor, temperature. Treatment. So this is treatment. Okay, treatment come from factors. Factors come from independent variable. Okay, treatment. How many treatment we have here? 1, 2, 3, 4. Treatment 1 is 750 degrees C. Treatment 2, 800 degrees C. Treatment 3, 850 degrees C. Treatment 4, 900 degrees C. So treatment denoted by K. K equals to 4. Alright. From the dependent variable, we can know what? Replication. Replication is for each treatment, how many experiments you do? 1, 2, 3, 4, 5. So the replication is equals to 5. For each treatment, number 2, how many replication? 1, 2, 3, 4, 5. N equals to 5. Okay, first your independent variable. Second is your dependent variable. Third is your factor. Fourth is your treatment. 5 is your replication. Okay. Write down the model, assumption and rules of the one-way ANOVA for the given data. So what is the model? Here is the model. Mu plus alpha I plus epsilon yj, where I equals to 1, 2 until k, right? So our k is equals to 4. So that's why 1, 2, 3, 4. J is 1, 2 until n. N is your replication. So our replication is equals to 5. So that's why 1, 2, 3, 4, 5. Okay, the assumption, you can write down the assumption just now in the slide we have, and also the rules. Okay, done. State the dependent and the independent variable. So the dependent is the tensile strength. The independent is the temperature. Okay, perform the ANOVA method and test the hypothesis at alpha 0.01 that the mean data provided by the tester is the same for all the temperatures. So the question asks you to test, is it the mu1, mu2, mu3 is all the same or not? So we can use the one-way ANOVA method. So step number 1. What is step number 1? Your hypothesis. H null and H1. How many treatment we have? 4. So that's why mu1 equals to mu2 equals to mu3 equals to mu4. Or you can write down all population mean is equal or similar. So for H1, you can write down mu I not equals to mu j for at least one I not equals to j, where j equals to 1, 2, 3, or 4. You can write down at least one population mean is not equal. Okay, use word here, not use symbol. Use word. Similar or not similar. Done. Step number 1. What is step number 2? Step number 2 is your F test. Okay, so in order for you to calculate the F test, what you need to do? You need to construct the ANOVA table. In order for you to construct the ANOVA table, you need the SSTR, SST, and the SSE. So this is the first step. So this is the table from the question just now. Temperature 1, 2, 3, 4. So this is the replication. First, you sum up treatment 1. Sum up treatment 2, sum up treatment 3, sum up treatment 4. Okay, and then you get all the summation of the treatment. And then you total all. Okay, total this one plus, you will get the 350.43. Next step, you want to find SSTR. SSTR is equals to each of the treatment 96.80. You square it, divide by number of replication, plus 94.96 square divided by 5 plus 82.32 square divided by 5 and plus 67.35 square divided by 5 minus total 350.43 square divided by 20. What is 20? Total data. You will get 48.6, 58.6501. Okay, so how about total? Total is each of the data. Okay, each 19.72 square plus 20.88 square plus 19.63 square plus 18.68 square plus 17.89 square plus until 13.25 square. Okay, you plus all each of the data, you square it, and then minus total square divided by total data. You will get 95.4875. So done SSTR, done SST. How do we get SSE? SSE is SS total minus SSTR. So SS total minus SSTR, you will get SSE. Done for SSTR, done for SST, done for SSE. You can put into this ANOVA table. Okay, this one is the SSTR that we calculate just now. This one is SST that we calculate just now. And then how do we get 36? SST minus SSTR, you will get this one, SSE. Okay, this one, 19. How do we get 19? 19 is n minus 1. Total data is 20 minus 1, you will get 19. How do we get 3 here? Total treatment minus 1. K is equals to 4. So 4 minus 1, you will get 3. How do we get 16 here? 16 here is 19 minus 3. 19 minus 3, you will get 16. Okay, next, mean square. Mean square treatment, MSTR. How do we get? So SSTR divided by 3. We will get the MSTR. How do we get here? MSE equals to SSE divided by 16. You will get the MSE. And last one is the F test. How do we get the F test? MSTR divided by MSE. You will get the F test. So 8.4915. Okay, next, the critical value. So as mentioned, F alpha nu1 nu2, where alpha is 0.01. Nu1 is degree of freedom treatment 3. Nu2 is degree of freedom error, which is 16. So look at the stat table. Find F alpha nu1 nu2. You will get 5.2922. Okay, done F test. Sorry. Done F test, done F critical value. Compare, reject or accept H null. Since our F test is 8.4915 greater than F critical value 5.2922, we have to reject H null. So what will happen if we reject H null? Go back. We reject this H null. So at least one population mean is different. Okay, so that's all for the one-way ANOVA. First, the hypothesis. Second, you need to find this F-test. In order for you to find this F-test, you have to go through all these steps. Before you have to find this F-test, you have to go all these SSTR, SSE, and SST. Okay, and then you find the critical value, you compare, and then you make a conclusion. Okay, so let's try the exercise.
4.2. Suppose the computerized vehicle inspection Puspacom was to examine the safety of private cars between Myvi, Persona and Toyota Camry. 3 samples of pressure applied to the driver's head during a crash test from each types of cars are collected and the data is given follow. So they talk about the safety of the private cars. Okay, so they examine the safety of the private cars by collecting the data of the pressure, right? So the pressure applied to the driver's head during a crash test. So the pressure is depends on the car they use. Okay, the car are divided by Myvi, Persona and Camry. Okay, so now here we know that sorry. So now we know that the pressure depends on the type of private car. Okay, so the dependent variable will be the pressure and the independent variable will be the type of private cars. So that is the dependent and the independent variable. So from the independent variable we know what is the factor. What is the factor? Factor is the type of private car. Okay, there's only one factor, that is type of private car. So from the factor, we can know the treatment. Okay, so how many treatment we have? We have Myvi, Persona and Camry. So K is equals to 3. Right. So now we know the dependent variable, we know the independent variable, we know the factor, we know the treatment. Now replication. N is replication. Replication. So replication come from dependent variable. So look at our dependent variable, the pressure. For each treatment, let's say Myvi, how many replication? 1, 2, 3. So N is equals to 3. Alright, A. Write down the model, assumption and the rule. So actually for A, you can just refer to the slides and then just write down the model. So this is the model where A equals to 1, 2, 3 because K equals to 3 and J 1, 2, 3 because N is equals to 3. So this is the assumption. Alright, B. Identify the control and response variable. So control also equals to independent or dependent variable. Independent variable. So the control is type of private cars and response is dependent variable. So dependent variable is the pressure. Okay, so how many treatments involved in this experiment? Treatment, so here treatment K is equals to 3. So number of treatments involved 3. How many replications involved? Replications come from dependent variable equals to 3. Okay, done. So D at significant level 3%, so alpha 0.03, test whether the mean pressure applied to the driver's seat rear carcass is equal for each type of car. So they ask you to test is it the mean for each of the car is equals or not, right? So the H null is mu1 equals to mu2 equals to mu3, or you can write down all population means are equal. Okay, so H1 mu I not equals to mu j for at least one I not equals to j, or you can write down at least one population mean is different. Okay, so next step, this one is step number 1. Step number 2, you want to find F test. Okay, in order for you to find if F test, you have to create the ANOVA table. Okay, so where's the ANOVA table? So this is the ANOVA table. Okay, in order for you to fill in the F test, you have to go back here. Okay, first you need to find this SSTR, SST and SS error. Okay, so now first what you need to do is find summation of my V. 6 plus 3, 643 plus 655 plus 702. Okay, and then 469 plus 427 plus 525, then 484 plus 456 plus 402. Okay, let's look at Pro 2 my V. You will get, okay, 643 plus 655 plus 702. You will get 2000 here. And then 469 plus 427 plus 525, 1421. 484 plus 456 plus 402, you will get 1342. Okay, after you find the summation each treatment, you find the total. Okay, 2000 plus 1421 plus 1342. Here you will get 4763. Okay, next. Okay, after you find this one, next you have to find SSTR. SSTR is equals to 2000 square plus 1421 square over 3 plus treatment 2 square over 3 plus treatment 3 square over 3 minus total square over 9. You will get this SSTR. And then find SS total. How to find SS total is each of these you square. Square, 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 square. Then you add it up. 643 square plus 655 square plus 702 square plus 469 square until 402 square. Here. Okay. And then you minus total square divided by total data 9. You will get the 59303.5556. Take up to 4 decimal places. 4 titik perpuluhan. So how do we get SSE? SSE is equals to SS total minus SSTR. So this one minus this one, you will get 10254. So after you get all the SSTR, SST and SSE, put it into this one. Okay, so SSTR is this one. So 86049.5556. So SST 96303.5556. SS total 10254. Okay, how do we get the degree of freedom? Degree of freedom, so total is n minus 1. N is total data. How many data we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 1 is 8. Okay, degree of freedom treatment. Degree of freedom treatment is K minus 1. K is equals to 3. Sorry. K minus 1. Allah. K minus 1. So we get 3 minus 1 equals to 2. So here is 2. So how do we get degree of freedom error? 8 minus 2. So equals to 6. So now how do we get mean square of treatment? So mean square treatment is this one divided by 2. 86049.5556 divided by 2. Right? So here you will get, so press the calculator, you will get 43024.7778. Okay, now mean square of error. How do we get mean square of error? 10254 divided by 6. So you will get 1709. So F test. How do we get F test? MS treatment divided by MS error. Okay, we use this one. Okay. MS treatment divided by MS error. You will get this F test. So the F test, you will get 25.1754. Okay, F critical value. F critical value is F alpha nu1 nu2, where your nu1 is degree of freedom treatment, nu2 is degree of freedom error. Degree of freedom treatment V is 2, degree of freedom error is 6. So you find F alpha is 3%, so 0.03. So F 0.03, nu1 is 2, nu2 is 6. So look at your stat table. You have 6.6549. Okay, so now complete your your ANOVA table. After you have done complete your ANOVA table, okay, this one was still in step number 2. Okay, step number 3, from stat table, we know that the F test is equals to 25.1754. F critical value is equals to 6.6549. So, step number 4 here, since F test is equals to 25.1754 is greater than F critical value 3.6549, you have to reject H null. Okay, so if you reject H null, what will happen? You reject this H null. So at least one population mean is different. So at alpha 0.03, at least one of the mean of the grade is unequal or is different. Okay, so please try do exercise 4.2 number 2 here about the sun glow, microshine and X glow. So please submit exercise number 2 through through Google Classroom. Okay, thank you.